This could be your ship. It could be any ship of the United States Navy. The watch is posted and the ship is secure. But is it? Behind the familiar bulkheads, at duty stations throughout the ship, even in the wardroom pantry in officer country, a silent shipmate lurks, ever willing and able to help you in your work, but also ever ready and able to kill, silently, swiftly, very swiftly. Your deadly shipmate is a friend the majority of the time, easing much of your work, lighting the way, and illuminating the darkness for you. Your deadly shipmate is low-voltage electricity. Yes, low voltage, not the high-voltage kind whose warning hum and warning sign of danger that no one ignores, not that kind of electricity. 115-volt current is deadly because it is so familiar. You've known it all your life. It drove your electric train when you were a kid. Gave you light to do your homework by. Showed up the fuzz on your face first time you tried to shave. But because 115-volt electric current is so familiar, is why it can be so deadly aboard ship. 115-volt current can kill. The Navy knows it. The Navy is always vigilant to eliminate the fatal hazard of electrical shock. Navy tools and wiring are expertly insulated. All tools are grounded. Plug caps are required on all shipboard electrical outlets. Wherever electrical gear is used aboard ship, rubber matting is laid down to insulate your footing. You are warned away from exposed electrical installations in short, clear Navy language. And Navy posters dramatically picture the cost of carelessness where electric current is concerned. Carelessness. Ah, there's the key word. Carelessness. And carelessness is a guy named Joe. This Joe will show us typical incidents in which men are killed by electricity aboard ship. These are not dreamed up. Cases like these actually happened. Joe could be you, sailor. Joe, or Tom, or Willie, his name's not important. The fact that he was careless with 115-volt current is. Joe brushed against the exposed filament of a broken bulb one day, and a telegram was sent. Joe drilled into an electrical conduit on duty one bright afternoon at sea. And his next of kin were notified. In the old Navy, decks were scaled by hand. Not long ago, though, a faulty power scaler shorted out. Joe started a job he never finished. The broken ground wire on a movie projector became another fatal trap. An official notification was sent. It happens many ways. An unauthorized fan is smuggled aboard, plugged in without the required ground wire, turned on once. Joe, or Tom, or Willie, was the victim of a shipmate's carelessness, too. His shipmate will never forget that he switched on the vent fan that Joe was repairing. The notification didn't spell out the cause of Joe's death. It wouldn't have helped. Nor could the fact that a sailor was impatient to get at a piece of toast have comforted his next of kin. Yes, it's a deadly shipmate, this 115-volt stuff. The reason is easy to understand. Electricity is power put to work for us under conditions we control. But electricity, even low-voltage electricity, gets out of control if we mishandle it or if we forget its potential to kill. Electrical current must travel, therefore, through a circuit which we know is secure at every point, whether we can see the entire circuit or not. We must remember that electricity, like any force, will always follow any path it can get through. Also, we must realize that aboard ship, we're surrounded by metal. We walk and sit, and work, and sleep, surrounded by metal. And metal is an efficient conductor of electricity. So, if we build ourselves into an open electrical circuit through careless contact, the current uses our body as a conductor and passes into the overhead, the bulkhead, or the deck. Because we're often wet with salt water or honest sweat, our bodies offer little resistance to the current flow. And when current passes through a vital organ, that's it. There would probably never be an electrical accident if electricity were visible, like water, for instance. If you reach over your head to prod a weak spot in a cold water line, and the line ruptures at that instant, the water flows down your arm and, obeying the force of gravity, continues until it reaches the deck. All you are is wet. But if you visualize that flow of water as electricity and accept the fact that electricity doesn't merely run down along the outside of your body, it passes through, why, you can easily understand how fatal electric shock can occur. When the body, your body, is a conductor for low voltage current, fatal shock can result. That's the story. Knowing this could be the difference between life and death for you. Yet, in spite of the easy-to-understand facts, the Navy has had the tragic duty of announcing the loss of men because of carelessness with or mishandling of 115-volt current, the deadly Shipmate. Let's review the cases we've seen and see how they happened and how they could have been prevented. Joe's job was routine enough. His assignment was to clean the inside of a steam drum. Quarters were tight and bright illumination was needed. Joe decided he needed a larger bulb. But the bulb was too large for the guard. He made the fateful decision to leave the guard off. It was hot in there. The sweat rolled off his body and his hands grew slippery. Yes, he dropped the light. The charged filaments were exposed. You know the rest. A simple act, like bringing in another extension light to double the brightness, and this fatal accident would never have occurred. Joe was installing a sound-powered phone. Simple inspection of any area into which he planned to drill would have prevented this second tragedy. It's standard Navy procedure because it can never be assumed that the other side of a bulkhead is clear. Check it, sailor, and live to answer Liberty Call next time. Yes, carelessness is a guy named Joe. Sometimes carelessness is just another name for laziness, too. Joe could see the frayed lead to the deck scaler he planned to use. He looked at it, wiggled it, and gambled. The stakes were pretty high. Sure, even Navy tools wear out, but the Navy provides repair facilities for such items. Had Joe simply carried the scaler with its worn lead down the ladder to the electrical shop, well, he'd be scaling a deck today perhaps, and looking forward to his next leave. This started out to be fun. Unauthorized fun, of course, but Joe and his buddies were willing to risk it. After all, a private showing of the wild women of Watusiland was worth some risk. So Joe liberated a movie projector. No, Joe wasn't an authorized operator, but he had seen it done any number of times. No, Joe wasn't dumb either. When it was noticed that the movie projector's plug was broken, Joe didn't want to take any chances, so he told his buddies to pipe down while he fixed it. Only trouble was, Joe was no electrician. No one had ever told him that the green wire was the grounding wire. And no one in the group knew that he'd rewired the green wire in the plug incorrectly. At last, the private screening of the Wild Women of Watusiland was ready to begin. Joe switched on the projector. Only trained personnel are authorized to operate a movie projector. Joe wasn't. That was mistake number one. Generally, only trained electricians are conscious of the importance of proper wiring of any piece of electrical equipment. Joe wasn't. That was his last mistake. Another set of circumstances and events began at the moment this sailor spotted a beat-up electric fan on a salvage dump one day. Visions of cool breezes in his somewhat stuffy quarters below decks clouded his judgment. Not every man is or should be searched as he boards ship. So the fan was easily smuggled aboard, in violation of some pretty clear-cut rules about unauthorized equipment. Joe had the perfect spot to put the breezemaker, right alongside his bunk. Of course, the ungrounded fan had a plug with only 2 prongs, and the receptacle was meant for 3. Fatal electric shock is no subject for humor, of course. But Joe is beyond wanting a cool breeze. And 115-volt electric current, the harmless kind, has claimed another victim. The tragedy began here, was made possible at the gangway, and made a certainty when this man failed to realize that the third opening in the receptacle was designed to receive the grounding prong of authorized Navy electrical equipment. Don't let it happen to you. Perhaps even more tragic is the careless act that causes the death of a shipmate. Here's what happens not too long ago aboard a destroyer on routine patrol. A set of bearings on the vent leading to crew's quarters needed replacement. Joe took the work order and carefully cut the juice at a motor controller so that he could work on the vent. He tagged it as required and felt perfectly safe as he crossed from starboard to port to begin his routine task. Below decks, the off-watch immediately noticed that the cooling vent had stopped pumping air into the warm living compartment. At times like this, there's always a volunteer, you probably know. So this sailor offered to go topside and check the motor control that operated the fan. Sure, lots of yeomen know all about motor controls. At the moment he energized the line, the eager volunteer spotted the fallen tag, a moment too late. Sure, you might say Joe's carelessness in not securing the tag properly in place was to blame. You might say the sailor who operated equipment not within his authority should be blamed. Say they both feel bad, but Joe is beyond any feeling. It can happen anywhere on the ship, like it happened to Joe or Tom or Willie. The name or the place isn't important. The scene is the wardroom pantry. Joe hankers after a midnight snack, and there's no one around to remind him that he's about to commit an unauthorized act. Toasters do jam sometimes. This one did. A fork can be used to fish out the elusive slice of toast. This one was. Metal toaster, metal countertop, metal fork. All metal, plus 115 volts of electrical current. The deadly Shipmate. Yes, electricity is a friend, ashore and afloat. High voltage lines supply the big jobs that man has harnessed electricity for, while low voltage is channeled into our homes and ships or generated afloat. It's a force we've lived with and depended upon since childhood and grown all too familiar with. We know its nature and respect its strength. We know it can kill. We're protected against its dangers by a Navy which uses every possible means to alert us. We use the 115 volts of our familiar circuits in countless ways and find our work easier, our comfort certain as a result. Still, the Joes and Toms and Willies with whom we put to sea fail somehow through carelessness, through disinterest, through simple lack of respect to live the number of years they're entitled to. So you do two things. You obey the rules made for your safety, and you constantly accept responsibility for the safety of your shipmates. That's the entire story of 115 volts, the deadly Shipmate.